Okay.
Hi.
So I'm having trouble with like the stuff we did on number 5. Pretty much that's just what
Okay, so
at some point on those ones.
want us to do do you want to ask about this one, or do you want to just start with a new one from scratch?
I'd like to just start with a new one.
Okay. All right, let's try this one here. So these are the formulas we'll be using. Start with the width, and then start putting that information into the limit definition. All right, give you a minute to try that, and then I'll come back and see what you get. Okay, 1 second, guys. All right, Nolan, how did you start this?
Well, with the width,
Uh-huh.
I just added 1 minus -1 over n. It's 2 over n.
Okay. What does your area formula look like?
Area formula would be 2 over n
Mm-hmm.
times f of -1.
Good.
Plus 2 over ni.
Good. All right. That's what I had too. All right, what's next?
Next we plug in the equation for f of x.
Right. So let me see you try that. Can you insert it correctly into the function?
Okay, let's see. So it'd be 2 over n times 2 minus 3 times -1 plus 2 over ni squared.
Okay. Yeah, I'm filling in these spaces there. Yeah, that's what you got, right?
Mm-hmm.
Good. All right, so now all the effort is just inside those parentheses and brackets and just trying to cleaning all that up. So let me know when you want to check the next step.
All right, so I got 1 minus 4 over n I
Okay.
plus 4 over n squared I squared.
Good. All right, keep going.
So we just like kind of balance that out now.
Yeah, so we're going to distribute the -3 through, and then we can combine like terms.
Where's 3? All right, I got 2 minus 3 plus 12 n over 12 over n I plus 12 over n squared I squared.
Yeah.
All right, and then you just multiply the 2n through.
Yeah, I combined the 2 plus 3 first, made it 5, and then I distributed the 2 right there.
Mm-hmm. All right, I got 10n plus 24 over n I plus 24 over n squared I squared.
Okay. Let's see.
Oh yeah, I'd square the bottom. Or you have to, I forgot you have to multiply those.
Yeah, so sure do that.
That's Let me find out. I'm not sure exactly what I have to do next.
Okay, so we're going to assign a summation for every term.
Mhm.
Okay. So it's going to look like this. So you've gotten through all the hard part already. So the rest is just knowing these specific procedures. We're going to push these coefficients out because we want these rules to be very easily identifiable. Right? So anything that doesn't fit the rule, we'll just go ahead and place them out in front. So I'm going to push the 10 over n out in front. I'm going to push the 24 over n squared out in front, 24 over n cubed out in front, and that's going to help me match my rules a lot cleaner, right? There's summation 1 will appear, summation I will appear, summation I squared will appear. Right? Let me know when you're ready for the next step, or if you want to try the next step on your own.
All right. I was wanting to find out what n equals, because
Okay, so I'm going to make my substitutions, right? So this is are you good from here to here?
yeah, I understand how you get there.
Okay, so now I want my degrees to match, right? Because we're doing with infinity. The nice thing about infinity is that if I get my degrees to match, then my limit is just going to be the ratio of the coefficients. So 10n over n, my degrees match. My limit is just going to be 10 over 1 because my exponent, they're both 1s, right? Here, if I distribute the 24 through, I get 24n squared plus 24n. I don't care about the 24n. I just left that out. I just care about my highest exponents. So because my degree matches, I'm doing limit as n approaches infinity. If my degrees match, my limit is just going to be the fractional value of my ratio.
So you just want the highest.
Exactly. Yeah. So
You
for
don't
each
have it.
fraction, you're just going to pull the highest degree. Everything else we could care less. So this looks like a mess to expand out. So, but we don't need everything. We just want the 24, the n, the n, the 2n.
And you want the exponents on each, like on the bottom, the numerator and denominator have to match, right?
That's right. That's right. You see the degrees match. So every fraction, every term, you're looking for a common degree. So every fraction, every one of these terms should produce their own fractional value.
All right. Thank you.
Okay. I got a few more minutes here. Any questions the rest of you have?
Mr. Yang, where is that formula sheet located on your website?
I think I put all this at the end of the quiz reviews. So if you access any of the quiz reviews, I put it as the third page.
Okay, thank you.
Yeah. And I'll also include this as the third page of your quiz too. So in case you misplace it.
All right. Thank you.
All right. Anything else? I encourage you guys to work through the rest of worksheet 2 that we didn't get to, and then if you want, maybe go through worksheet 3, because if you can do worksheet 3 from scratch, you should feel confident. But if you have any questions, you can ask me tomorrow morning, or if you want to wait till tomorrow morning to work through worksheet 3 as well, that's fine. Just giving you some options. All right, I'll see you guys tomorrow.
Thank you.
All right,
Thank
see
you.
Bye.
Thank you.
Thank you.
Mm-hmm.